Welcome to CEO Money. I'm Michael Yorba. Thanks for joining with us. I have John Vandermosten with me. He is with Zacks Small Cap Research, and he is their lead biotech analyst, my favorite biotech analyst. John, welcome back.
All right. Thank you, Michael. It's great to be here.
I'm glad you're here. All right. You've been hard at work. You've been in conferences, zipping around the globe. Let's talk about gene therapy. That's something that's real hot these days. I want you to bring out for our audience first what it is, and then what's going on in that industry sector.
Sure. As you said, it's really hot. There are a lot of deals getting done. If you've been watching the financial news, you've seen a number of these happen in the last couple months.
I have.
So to answer your first question, what is gene therapy? I think we've been hearing about it for a long time. One of the first big deals in gene therapy was back in the 90s, where they essentially cured that bubble boy disease. Mm-hmm. There were a couple of girls that received gene therapy, and instead of having to be in a sterile environment, they were able to live a normal life, and they're still alive today. That's almost 30 years ago now. So, that's pretty exciting what it was able to do. There have been some problems with it, though. There were some oncolytic events, some cancers that people suffered from as a result of it, and then one patient actually died from gene therapy. So, there's been some good and bad things that have happened. But basically what gene therapy is it takes a transportation device, which is called a viral vector, to get new DNA into your cells to replace defective DNA. Mm-hmm. So it's actually, it's a really simple concept when you think about it that way, but when you get into the details, it's a lot more complex. But you're using these viral vectors, which are pretty interesting because viruses have evolved to be very effective at entering our cells. When you catch the flu or, some other virus, you caught it through the air, it was able to go into your system, evade your immune system, and then infect your cells and get you sick. So what science has done is it's taken these viruses out there, and there are plenty of them, some of them more effective than others, and taken away the bad viral material and replaced it with missing genes, and then they infect you with that. And it sounds bad to be infected with a virus, but it actually is a good thing when it's being done by physicians who are trying to help you, and it puts this gene into your cells and fixes that broken protein, and after that, in many cases, you're cured of a disease.
Yes, and I think that we're going to be living a lot longer and better quality lives through this technology. So let's move forward here. The concerns of gene therapy that you've got.
Yeah, as I mentioned before, there were some cancers that some people suffered from as a result of it, and those were due to what are called off-target effects, where the genes are actually put in the wrong place. If you think about DNA, you see this big, long double helix, right. And instead of putting it where it needs to go, it puts it maybe a little bit somewhere else, and then that has some negative impacts, and some of those were cancers. And then also what can happen is some of these viral vectors, if an individual has had exposure to that virus before, they may react to it again. Even though it's not a damaging virus, it will set off their immune system, and they'll have a very severe effect, which it led to one patient's death. His name was Jesse Gelsinger, and in 1999, it's 20 years ago now, but he had a severe immune response to the viral vector that was used, and he died. So it's a very complex and in some ways dangerous thing. But the good news is that we've figured out a lot of these problems, and we've resolved them, and we've also made a lot of progress as well, making it a little bit more streamlined, taking out some of the unnecessary parts and fixing the parts of it that weren't right.
Got it. Now, the deal's getting done. Tell me about these.
Yeah. So, I think there's been actually put together a list of about 7 or 8 of them that have gone gone by. But the recent one that's probably got the most attention was the Spark and Roche deal, and that was a $4.8 billion deal. And Spark actually had the first gene therapy approved by the FDA, and I think it was December of 2017. It's for a type of blindness. So they got taken out just a couple months ago by Roche, and they actually have a pretty big portfolio of other things coming down the line as well, and also using gene therapy. So, I think that approval of Luxturna was somewhat of a turning point in the industry, because when the FDA finally understands a new type of therapy and they approve it, I mean that takes a lot of the risk to taking new ones through the agency. So that was a pretty good piece of news. And then there have been some other big deals out there. I think the biggest one was Novartis and Avexis, and their drug is for spinal muscular atrophy, and that actually I think is going to get either approved or disapproved this month. That drug. So we're right on the cusp of something happening there.
What's this retinal diseases? What's going on with that?
Sure, yeah. So, a lot of those are what are called monogenic diseases, and these are the area where gene therapy is most effective. And monogenic just means it's one gene, right? So they just have to fix one gene. If you add on more genes, it gets, from what I understand, exponentially more difficult to solve the problem.
I would think.
Because there's several different places along the genome where you actually have to, replace and repair. But yeah, so retinal diseases, that's a big area, just because it's very conducive to that monogenic repair of the defective gene.
I'm looking through these, and the lysosomal storage disorders and Batten disease. What's this?
Yeah, well, so those are a number of other indications that are just amenable to this kind of approach. And what you said, that's for Selenex, and Amicus. They had a deal with Selenex for some of those indications.
Okay. So of the list here, looks like you got about 6 or 8 of them.
Yeah.
Which one is really most intriguing to you that has the biggest impact on changing human life?
Yeah. Well, and about a month ago in the news, there was, do you remember the bubble boy disease?
Yes.
I actually mentioned that before.
Yes.
That even though there were some patients cured of that, there was never an approved therapy. And there's a company right now called Mustang Bio, and they're working with St. Jude Children's Hospital to come up with a gene therapy to address this. And several of the patients actually are showing that they've been cured. I think we have to wait a little bit longer, and they have to go through a phase 2 trial. But Mustang Bio is really on the ticker symbol MBIO. They're really on the cusp of really achieving something here. It is a rare disease, so the number of patients is limited. But just the fact that they're able to show some successes here is pretty good. So
what's your favorite one?
Well, there's a private company called American Gene Technologies. They're a little bit earlier in the in the human clinical trials than Mustang Bio, but they are working on a platform approach to use gene therapy where you have a viral vector that works, or a set of viral vectors, because each one of these viral vectors, you think of the media used to transmit information. I mean, sometimes we use like the computer analogy, right? So you maybe have a floppy disk or a CD. They all have different uses. So that same thing applies to viral vectors. I mean, you can have several different types of viral vectors depending on what you're trying to do. So what AGT, or American Gene Technologies, has done is they've put together a set of viral vectors, and then they've opened them up to where they can put the necessary gene inside of them to deliver it to the cell that needs to have it. So it's really just a plug and play, where you take this part out and this part out. It's, I envision them opening up drawers and putting a viral vector out, and then this gene code that's necessary. It's really exciting if they're able to do it. So, again, as I said, they're really in the early stages right now. But if they're able to do this, they'll be able to solve one of the biggest issues with this, and that's cost. And we didn't talk about that. But
bring it out.
Yeah.
So bring it up.
So a lot of these are running in the $500,000 range for these therapies, which really is not affordable. Sometimes the case can be made that this actually is saving the system money over the long run, because they cure the patient, and to care for the patient, to provide them treatment over year after year after year, that could actually exceed, the $500,000 to $700,000 it costs for the one-time treatment.
Right.
But still, it's very difficult to get over that cost. So if this company, American Gene Technologies, is able to go out there and really reduce the cost, streamline what needs to be done, and do it in an efficient, safe, and effective manner, then they really will be able to clean up. They'll be able to cure diseases rather than just treat them, right? So there's immense value there. And then they'll also be able to do it at a reasonable cost, which is, I think right now, because of the strains on the healthcare system, is probably one of the most important things that can be done.
I would agree.
Yeah.
Be able to get it up. Is there anything else you want to bring up before we close?
Let's see. I think gene therapy is probably one of the most exciting things out there, because it really, when we hear about treatments, we think, they're gonna solve something temporarily, but it will be a chronic condition that'll go on and on and on. But gene therapy is actually going to the root cause of the problem, right? It's able to get in there and fix it, and once it does it, theoretically, it hasn't been proven out yet, but you'll be cured. You won't need that treatment anymore. And I was quoted by one of the CEOs that I spoke with. There are about 7,000 different monogenic diseases that could be addressed by this. They're very small, but just think of that.
Wow.
So amazing stuff.
It is. All right, John, thanks for being here.
Oh, you're welcome.
All right, you've been watching CEO Money with Michael Yorba. Thanks for joining with us. Like us on Facebook, follow us on Twitter, and subscribe to our YouTube channel.